Evening. I'm Spot On Weather meteorologist Matthew Euler. Welcome to tonight's video. It's been a little bit since I did my last video, and I certainly hope everyone is enjoying the holiday season at this point. Tonight's video I'm titling Topsy Turvy. Why am I titling it this? Mainly because of how we went from a very cold period over the Christmas time frame, the Christmas holiday, from Friday the 23rd of December. And even now, tonight, here on the 27th of December, you still feel that cold lingering, specifically after sunset, after the sun goes down, as temperatures have pretty much continuously dropped into the 20s across many areas of the mid-Atlantic, but fairly cold across the eastern United States as a whole. And what happens is you get this very cold, dense Arctic air mass, and it's very hard to move out of the way, being so heavy and dense. It doesn't readily move out of the way at all, and sometimes the models tend to move that cold air out too quickly. The models have done a fairly decent job. The models have so far to this point, just showing the gradual warming trend that we're currently undergoing. Nothing drastic or too quick. Overall, we are heading towards a topsy-turvy situation from bitterly cold, record cold Christmas time period to a milder New Year's period right on into the first week of the 2023 year. And by the way, here is our title graphic tonight on the title slide. Happy New Year 2023. Boy, it's coming up quick, isn't it? Really, 2022 was pretty much a blur. And now it's definitely going to the rear view, into the rear view mirror now. But let's go ahead and take a look at things. And I want to start tonight's video by explaining, let's break this down here. What is going to cause this return, or this change to milder weather, from very cold to milder weather? What's going to drive the milder temperatures across many parts of the United States, but specifically the eastern United States? It all starts, first of all, with a Pacific jet stream. When it's strong, and that stronger, higher wind speeds are denoted by these brown colorings, lighter white shadings or colorings, darker brown colorings, as well as darker orange coloring. Whenever you see these colors, that indicates very strong winds at the jet stream level, at 300 millibars above the ground, or about 30,000 feet above the ground. All right, so we look at the 300 millibar chart to analyze for the location, the placement of the main jet stream axis. And you can see here on the latest European ensemble run, this is the actual forecast for today, the 27th of December 2022. Notice how the jet stream across the Pacific Ocean is oriented in more of a zonal configuration from west to east. Noticing this? And then also how high these wind speeds are. The whiter coloring here, if you look at the scale here on the right, that whiter color is wind speeds in excess of 184 knots. So we got some very strong winds blowing pretty much from west to east, from Japan right on across the Central Pacific, all the way to the East Pacific. And you can even see portions of that jet stream now extending into the western United States, Northern California, parts of northern Nevada, southern Idaho. And so as this west to east high zonal jet stream, this very strong jet stream this time of year in the winter season, because we have very strong differences in temperature between the higher latitudes to the north and the tropical latitudes to the south. You get a very strong temperature gradient, or temperature difference, across the latitudes in the winter season. But when you get this kind of configuration, that generally tends to allow for milder air to be pushed basically into the United States from west to east, from the west coast to the east coast. And over time, this milder Pacific air is going to flood the North American continent, and that's going to result in much milder weather. By the way, I wanted to mention that please disregard the bullets here at the bottom. Obviously, this is not the case for this particular image. So just what I ask is that you just listen in kind of as my voiceover kind of covers what's really going on. All right. Now, let's look at this, the air mass and jet stream review. All right, so we know that we have a high zonal west to east Pacific jet stream that's very strong, right? we do a review of the air masses here on the left, and you'll notice that from the Pacific Ocean, since we live in the mid-latitudes here in the United States, generally from 30 to 60 degrees north latitude, we are greatly influenced by what happens in the Pacific Ocean. And that's kind of like what I was hinting at here with this more high zonal, very strong west to east Pacific jet stream. So out in the Pacific Ocean, two main air masses that really influence the weather across the United States. The first one being an MP, or maritime polar air mass, which generally forms over the unfrozen waters of the North Pacific, which that air mass generally impacts areas along the west coast of Canada, as well as the Pacific Northwest of the United States. Now, typically in the warmer times of the year, in the summer season, you get something that's known as maritime tropical air, that warm, moist, and more muggy air mass that comes in from the tropical areas of the Pacific Ocean right into the southwestern U.S. Right, so we have maritime origin air masses, and what's the big difference between a maritime air mass versus, let's say, a continental air mass? Maritime air masses form over water, and water has a characteristic that does not allow rapid changes in temperature of the overlying air mass above it. Okay, so water tends to modify air masses, tends to make them milder, whereas continental, whether we're talking continental Arctic air masses, which we just saw across the eastern United States during the Christmas holiday, as well as the continental polar air masses of winter season. Maritime tropical air mass, again, is warm, muggy air coming up from the Gulf of Mexico, as well as the tropical waters of the Atlantic Ocean, the Western Atlantic Ocean. And then there's another maritime polar air mass source region up here over the unfrozen water bodies of the North Atlantic, which generally produces those very chilly and damp days across many portions of New England, as well as all the way down to the mid-Atlantic sometimes. But in general, we're going to be influenced more by maritime air masses as it moves in off the Pacific Ocean. We're not going to see very cold air. When you get a moist air mass, it tends to really not change in its daily temperature quite as drastically as if you get a continental air mass, where your morning low temperatures might be 30 degrees colder than the afternoon high temperatures with a continental air mass. So really, we tie in the air masses here on the left with this review of the jet stream. Okay, the purple coloring here indicates the configuration or the shape of the jet stream, the general axis of where it's at. So let's look at an example here between meridional versus zonal. With a meridional jet stream, you get more of a north, more of an amplified pattern with more amplified ridges. You get this amplified ridge extending further north in this example across Montana, and then you get a deeper trough downstream of what's known as an upper level ridge associated with this jet stream. So you notice how much more wavy this jet stream is. This is a meridional jet stream. And what a meridional jet stream allows is for colder air to move in more from the Arctic and from Canada down to the United States in the base of these troughs, and milder air to build highly amplified ridges, upper level ridges, also to build to the west of that trough axis. So with a meridional jet, we have more north to south transport of air masses, exchange of air masses, changeable weather. Whereas with a zonal jet stream, we have more of a west to east configuration to the jet stream, okay? And you get the coldest air remaining to the north, you get the milder air to remain to the south. And you really don't get much movement north or south of these air masses. Things kind of remain mild across the United States as a whole, and that's why I was showing you this west to east jet stream configuration, the zonal jet stream. Okay, I did update the bottom here on this particular slide. West to east zonal jet stream allows for that milder Pacific air. Look at this. I mean, if you look at the jet stream from California in this example all the way over to the mid-Atlantic, to the east coast, notice how the air is pretty much moving west to east from the Pacific all the way across the United States. All right. That zonal jet stream is going to allow that milder air to flood the North American continent during the winter season. You want more of a meridional jet stream, a deep trough in the eastern United States, to really, really get those colder air outbreaks, in addition to potential storm development. One other thing we need to talk about is when you get milder weather in the eastern U.S., it's usually a result of lack of high latitude blocking. And we've had some pretty significant high latitude blocking so far this winter season. Whether we're talking about November, late November, where we have this huge upper level ridge building into Western Canada and Alaska in association with a positive PNA and a negative EPO, a couple of our teleconnections I talk about frequently. We have that in late November, huge upper level ridge in the North Pacific into Western Canada and Alaska. We just had it happen again just recently prior to this very cold Arctic outbreak and the Christmas holiday. We also just recently had what's known as that negative NAO, North Atlantic Oscillation. Look at the purple coloring here. This is a very anomalously high height center located over Greenland, and this is in association with what's known as that negative NAO, North Atlantic Oscillation. So we have blocking, ridging or blocking extending very far to the north in latitude across. We can have it occur across the North Atlantic. We can have it occur across the Northeast Pacific. And when you just don't have this high latitude blocking, whether we're talking the Pacific side or the Atlantic side, what you usually get is more of a west to east jet stream. Okay, and that's really what's happening right now. If you look at this graphic here on the left, notice this red coloring here. This is indicative of higher than normal heights that are extending across the western portions of North America on this particular graphic. And then when you get these very strongly, highly amplified blocking patterns or ridges extending very far to the north, you typically get much colder air dislodged to the east of the ridge axis into parts of eastern North America. So the blue shading here indicates anomalously lower than normal heights. The reddish colors anomalously above normal heights. So this is like one of those split situations where I believe this occurred in 2013 and 2014, those winter seasons, when we just had that ridiculously resilient ridge and the warm blob of water over the Northeast Pacific. Okay, this brought some very cold air south into the eastern U.S. and also was a very active storm pattern that particular winter season in 2013, where there were multiple coastal storms. You have plenty of cold air in place, so a lot of this precipitation is going to be mainly frozen. So why are we going mild? Strong Pacific jet stream, number one. Number two, we look at the air mass. It's more of a maritime origin air mass that's going to flow across the United States from the west coast to the east coast, looking at a more zonal jet stream. And then we have a lack of high latitude blocking in the foreseeable future per the models, and I'll show you those ensembles here in a minute. In addition, we now have a strong stratospheric polar vortex. If we look at 10 millibars, actually this is 30 millibars above the ground here. So we're way, way high up in the upper atmosphere. And what happens in that second layer of the atmosphere, which is the stratosphere, really does make a difference on our weather where we live here at the surface, believe it or not. See the white solid lines here, these are your height contours. And whenever they take on a more circular shape like this, it's a more symmetrical shape, that shows us that the polar vortex in the stratosphere is getting stronger. It's looking more stable as it pivots closer to the North Pole area. With a stronger stratospheric polar vortex, the coldest air remains bottled up over the North Pole. And then typically with that stronger, more symmetrical or circular shaped vortex, you get milder air across the mid-latitude continents. And, whether we're talking Europe, or whether we're talking the United States, you generally get milder weather when you have a stronger stratospheric polar vortex, and that's where we're at right now. In fact, this forecast is valid for tomorrow, the 28th of December. And finally, another reason why we're turning to milder conditions is La Nina. You can't throw this out when you have a La Nina winter. The overlying atmosphere above these areas of cooler than normal water in the eastern Pacific and the central Pacific, and then the above normal water temperatures over the western Pacific, you can't discount what these kind of temperature anomalies do to the overlying air mass. All right, so typically when you have colder than normal water here off the west coast of Peru, for example, South America, you generally get more sinking air motion in the vertical, air sinking here. All right, so talking more high pressure at this point over the eastern tropical Pacific. Whereas above normal water temperatures here in the western Pacific, you get rising vertical air motion. Rising air leads generally to clouds and precipitation across the western Pacific in a La Nina winter. Sinking air in the East Pacific, rising air in the West Pacific, and then it's one big three-dimensional circulation cell in which you have the air rising, and then the upper atmosphere, it moves back towards this high pressure cell and sinks again at the surface. And so you can't discount the La Nina that's in place. It has huge implications on the general wintertime patterns across the mid-latitudes, specifically the United States during the winter season. Here is the latest sea surface temperature anomaly in that Nino 3.4 region, sitting today at minus 0.89 degrees Celsius, so just under 9/10 of a degree Celsius. But you'll notice the trend here in the last week, from the 20th to the 27th. See how this blue line, this temperature trace or temperature graph, is now going upward. It's climbing upward. It's kind of leveled off here today, but I can't remember, maybe about 10 days ago, the sea surface temperature anomaly in this Nino 3.4 region was sitting at about minus 1.14 degrees Celsius below normal. Okay, now it's at minus 0.89. So our temperature departures, our cooler than normal waters, that value is decreasing, which to me indicates that La Nina is finally starting to weaken somewhat. Again, you cannot underestimate the influences of the atmospheric circulation over these below normal and above normal areas of water, and how they impact our overall circulation in the mid-latitudes in the winter season. So, kind of covered, I started tonight's video showing you why we're going to milder conditions. Strong Pacific jet stream. There's our air mass review, more of a maritime air mass flooding the United States, maritime origin air mass. And then you got more of a zonal west to east jet stream instead of this meridional jet stream, which would allow for much greater temperature extremes on whether you're under the ridge, very warm above normal temperatures, or in the trough, much below normal temperatures when you talk about meridional jet streams. And then lack of high latitude blocking, we just don't see it. And then a stronger stratospheric polar vortex that's going to favor coldest air remaining up over the Arctic areas, milder air in the mid latitudes. And then La Nina is still holding up. It is now in a weak state. It went from moderate to weak strength La Nina, but it's still there. So now I'd like to move into the second stage of tonight's video, and I'm going to talk about, just compare the, on each of these slides I have the GFS ensemble graphic on the left and then the European ensemble on the right. And I'm just going to kind of walk through and explain these different charts. Again, please ignore the text here at the bottom on these graphics. I did not quite get a chance to update those, but I'm going to just voice over what I'm seeing. All right, so we're going to start things off running it through early January, starting off though on Friday the 30th of December. We're going to be coming up here this Friday on the final couple days of the year 2022. And what we're seeing here is any of these colorings here, when you see a darker orange or maroon coloring and a lighter brown, that indicates above normal heights. Wherever you see the greens and the blues, that's below normal heights, okay? Why is that important? I say it every video. Above normal heights associated with upper level ridging, and beneath upper level ridging we typically see dry conditions and milder than normal temperatures. When we talk about being in a upper level trough, that's generally associated with cooler than normal temperatures, as well as more unsettled conditions, more precipitation. So what we're looking at initially on this upcoming Friday, this Friday the 30th of December, we are seeing a massive ridge just centered over New England. All right, so you got plans to go to, coming up, I'm going to show you the New Year's Eve forecast, but you've got plans this holiday weekend coming up to go up to, say, New England, and you're hoping for snow. It's just not looking good with this kind of upper air pattern. You got this ridging. It's going to be warmer than normal and drier than normal, period. Now, there will be a little bit of moisture kind of sneaking in here from the south over time, and I'll show you what that looks like here in a minute. We will have some rain that's going to be over the mid-Atlantic down to the southeastern U.S. as we get towards New Year's Eve. But generally, the cooler than normal temperatures with the troughing is located out in the western U.S. For Friday, this Friday, the 30th of December. Here on the right, the European ensemble, pretty much in agreement with the placement of the features, very similar to Jeff's, where we got troughing over the Pacific Northwest. We also have a little bit of troughing down into Texas. We do have that strong ridging again into New England, basically, the ridge axis. By Saturday, the 31st of December, really no changes here. I really don't have much to tell you different from the previous slide here, the 30th. We will see as this boundary kind of sharpens between the milder temperatures. It's going to be a milder New Year's Eve for the southeast, the mid-Atlantic, up the East Coast to New England. But along this boundary here between the troughing over the central U.S. and the ridging here over the western Atlantic, you are going to see a frontal system, and you will see some rain that will move in, generally from the southeast to the mid-Atlantic. Looks like the heaviest rain. But again, some of that rain could extend northward up into New England as well. But overall, here we are on the right, showing you the European ensemble prediction system, showing that troughing again, remaining in place along the U.S. West Coast, specifically off of Oregon and Northern California. We do see a little bit of weakening on the European ensemble here on the right for that ridge on Saturday. Conditions look a little bit less, the heights aren't as high with the European ensemble here on the right. Let's take a look now and move ahead to the first day of the new year. This Sunday, the 1st of January 2023. We still see that ridging, see that higher than normal heights across, now extending a little bit further to the north over parts of eastern Canada. And both of the ensemble systems show this placement. Whether we're talking the Jeffs here on the left or the European ensemble on the right, very similar. We see some troughing that's deepening at this point into the desert southwestern area, whether we're talking the European ensemble on the right or the Jeffs on the left. We do see a definite trough setting up in unsettled conditions across California, Nevada, right on into parts of Arizona as well as Utah for the first day of the new year, this Sunday. We also see troughing over the northeastern Pacific Ocean, specifically the Gulf of Alaska. Moving ahead now to Monday, the 2nd of January 2023, we just see a continuation of ridging conditions across the Midwest, the eastern U.S. as a whole, all the way to the eastern seaboard, up to New England. See the coloring here, up into Canada, we have ridging going on. This is going to result in a milder temperature regime for the east, and the cooler than normal temperatures, colder temperatures will be out over the west in association with this trough axis as it moves slowly to the east. If you look at the graphic here on the right, the European ensemble showing a very similar situation. Troughing in the Gulf of Alaska, a little bit of ridging downstream of that, but it's weak. And then troughing again into parts of the Texas Panhandle as well as New Mexico. Forecast for Tuesday, the 3rd of January 2023. Look what happens again. It's almost like a repeat. See this? This is the forecast for this Friday, the 30th of December. And what happens over time is it's very similar. These abnormally higher than normal heights across southeastern Canada into New England. It's going to result in continuation of milder conditions along the eastern U.S. Cooler than normal conditions will be west of the Mississippi River by next Tuesday, the 3rd of January. We move ahead now to Thursday, the 5th of January, 2023, showing ridging across the western Atlantic Ocean, just off the New England coast, above normal heights extending northward into Canada. And then that trough just not making much progress to the east. See what happens over time? It retrogresses and just stays over the western U.S. in general, from the Aleutian Islands, Northeast Pacific, right on down into parts of New Mexico and Colorado. We look now, keep moving ahead here. Let's move ahead now to Saturday, the 7th of January, 2023, showing more of a west to east jet stream. We are seeing a weakening, a lowering of these heights here, this anomaly high height area. Not quite as strong now over southeastern Canada and New England by Saturday, the 7th of January. Models are having a hard time right now resolving really what's going to happen generally after the 5th of January. There's a lot of back and forth going on in the models over the last couple days. Some of the models want to dig a trough a little deeper in the east and cool things off, while other models are keeping it fairly mild. So we'll just have to watch how that progresses over time. We do see this trough retrogressing a little bit back to the west by Saturday, the 7th of January, where you get your lowest heights now further west. That's going to allow a little bit of more ridging here along the immediate coastline from Seattle, working northward all the way up through western Canada, as well as up into eastern Alaska. Let's take a look at the temperature anomaly forecast now. Let's start with the European ensemble mean. Up here, upper left, is the forecast anomaly in temperatures in degrees Celsius for 30 December, showing nothing but orange coloring, indicating above normal temperatures, as well as a slighter white coloring and browns. Over here on the right is New Year's Eve. Again, very mild overall across the eastern United States for New Year's Eve this year. Bottom left is the first day of the new year on 1 January, the New Year's Day forecast. Very mild, very mild eastern U.S. for New Year's Day. And then really a continuation of that. I moved it ahead now in the bottom right image here, all the way to 5 January, and you still see cooler temperatures along the U.S. western coast, but milder temperatures from anywhere from the Midwest to the East Coast down to the Southeast. Texas also warmer than normal on the 5th of January. Now, I went ahead and looked at the GFS Ensemble forecasting system as well, and very similar situation here. This Friday, the 30th of December, very mild, above normal temperatures across the eastern U.S. Looking at the upper right-hand graphic here for Saturday, New Year's Eve, the 31st of December, if you have any plans to go out and ring in the new year and be outdoors, it's going to be mild. You know, it's really amazing how this weather can change from such frigid conditions a week earlier to this a week later. It's just really mind-boggling, really. Looking at the bottom left here, this is the forecast for New Year's Day, the 1st of January, just remaining mild. It's going to feel very mild, especially after we were just used to such cold temperatures in the eastern U.S. around Christmas. And then bottom right showing the temperature anomaly forecast for the 5th of January 2023, really from the mid-Atlantic up to New England. That's the warmest temperature anomalies will be extending in those locations. A little bit cooler than normal across western Canada by the 5th of January down to the west coast. So where are we headed now? Okay, I explained why we're turning to a milder pattern. We just covered the latest European ensemble and the GFS ensemble upper air charts, see where the troughs and ridges are located, where the higher the normal and lower the normal heights are located. So now where are we headed? Let's start with the teleconnections here. Let's see if they give us any kind of clue as to where we potentially could be headed after, let's say, after the 5th of January. Okay. Upper left here, and by the way, I'm showing you the European Ensemble Prediction System, 50 perturbed members on all of these teleconnections forecasts. Right, so starting up the upper left here, I show the Arctic Oscillation, 50 perturbed members. This goes all the way out to the 11th of January. The green line representing the ensemble average or ensemble mean of all the 50 perturbed members, okay, of this particular ensemble system. Generally, what we're looking at slightly above in the positive territories as we go from the last few days of December into 1 January, and then generally neutral conditions through about the 5th of January as far as AO goes, and then dropping slightly negative. Not sharply negative, just slightly negative. Over here in the upper right, showing the North Atlantic Oscillation NAO forecast, the 50 perturbed members from the European Ensemble system, showing a positive trend of the NAO. You know how long it's taken to get positive on this for the NAO? I mean, we were sitting there negative and fairly strongly negative for quite some time in the month of December, but now the NAO has turned to a positive state. And that positive state will remain in place until about the 3rd of January, and then neutral conditions will then prevail pretty much all the way through the 11th of January. Looking at the bottom left, this is the EPO, East Pacific Oscillation Forecast. This thing has been all over the place. We've had periods where the EPO has gone strongly negative. We've had periods where it jumps positive like this. And then now we're looking at potential neutral EPO conditions from 4 to 11 January. Now we will see that positive period generally the last few days of December of the EPO into early January. But overall, in the longer term, we're looking at more of a neutral condition for the EPO. And the bottom right showing the Pacific North American pattern forecast, 50 perturbed members, European Ensemble, showing more of a neutral condition state to the PNA, and then trending more positive after the 7th of January. So this would be one of those favorable things that would give us colder temperatures in the eastern U.S. The PNA going positive, but really most of these teleconnections, you know, they're either slightly positive or very slightly negative. If anything, you know, it's closer to neutral on all of these, really. There's really no sharply positive or sharply negative situations in the latest teleconnections forecast. What about the MJO? We cannot forget about the MJO in the winter season. This thing can play a huge role in the upper air pattern, the jet stream configurations. Let's take a look at the forecast. Now, this forecast runs from today, the 27th of December, out to 10 January. The green line representing the average of all the GFS ensemble members. See, so each of these yellow lines represents an ensemble member from this specific run. Now, generally, the green is the ensemble average of all those yellow lines, all those different individual ensemble members. Overall, what we're looking at on the Jeff's forecast is MJO in phase 5, which we're seeing right now, and then it's going to transition right along that null phase in phase 6 area, and then maybe weekly into phase 7 as we get into the first week of January before we're curving back into more the null phase. We look at the GFS operational forecast here on the right. That would be this aqua, or actually the blue line here rather, showing phase 5, very similar to the Jeff's, and then the MJO forecast moves into the null phase pretty much. Looking at the CFS V2, okay, I kind of think of this as my fantasy model run here, but you can't discount the data, you still got to show it. So I figured, why not show it? Let's just take a look tonight to see what the CFS forecast is for the MJO. This is courtesy of Kyle McRitchie. Generally what we're looking at is the potential to be in the null phase, or potentially drift all the way out into phase 7, and turning closer to phase 8 potentially, as we get towards the end of this model run into late January. If we look at the temperature composites, I'm now showing you above versus below normal temperatures in the U.S. based on the MJO phases. If it's blue coloring, it's below normal. If it's orange coloring, it's above normal. So if you look at MJO phases 8, phases 1, phase 2, phase 3, that's all blue shading across the eastern United States in each of these cases. So phases 8 through 3 of the MJO feature colder than normal temps across the eastern U.S. during the months of January, February, and March. Now, if you like mild temperatures in the eastern U.S., you live in the east, you live in the Midwest, you want phases 4, 5, and 6, because that will generally lead to more of a southeastern ridge situation and milder temperatures. Even phase 7 is still fairly mild. What about the stratospheric polar vortex? We talked about it strengthening. We talked about it becoming more symmetrical in shape and appearance, retreating over the North Pole, keeping that coldest Arctic air bottled up in the short term over the North Pole. But what's going to happen in the future of this, the vortex, right? Now, notice now how these white solid lines, these high contour lines, are now more elongated. They're not as circular in shape. So there are signs, this is the GFS model run, by the way, showing more of an elongated situation and potential weakening of the stratospheric polar vortex. This forecast here is for the 9th of January. One other thing I want to mention and really get it out there to you at watching the video is more of the yellow and the orange colorings. This is the temperature scale here on the right. And you see whenever these stratosphere temperatures warm drastically, represented by the yellows and the orange colorings, that can result in what's known as a sudden stratospheric warming event, and that could result in either displacement off the poles of the stratospheric polar vortex, or result in an elongation or stretching of the vortex off the pole, or it could result, if this warming is strong enough, it could result in a much more significant disruption of the polar vortex in the stratosphere. It could actually lead to a splitting vortex. So this is real interesting. There's been signs over the last couple days of a potential weakening polar vortex in the stratosphere. Way too early to tell right now what's going to happen with this. These model runs are so variable and change from day to day. And it's pretty far out in the future. We're looking at the 9 January forecast right here. But just something to keep an eye on. Here are the final thoughts of tonight's video. I'm drinking water as I talk through this, by the way. I'm getting that tickle. The air is very dry right now. In fact, where I'm sitting at tonight in the mid-Atlantic and southeastern Virginia, I'll tell you, it's in the 20s again. It's very cold outside, and it's very dry. All right, so final thoughts on tonight's video. Mild air is set to invade the eastern U.S. And, the warm-up really begins tomorrow, the 28th of December, but I consider the 29th of December right on through the 5th of January a very mild air in place. Now, today's ensemble models are showing milder air remaining in place across the eastern U.S. all the way through the 10th of January. It's not what you want to hear if you want some exciting, active winter weather, believe me, I know. I'm kind of looking at these models lately and just going, oh, this is so uneventful. It's not even funny. But that's what we're facing right now. Now, there will be occasional cooler periods between now and the first week of January. So just because, you see something like this, right? These warmer than normal temperature anomalies in the east, that does not mean that we can't have a cool down in between the milder air. Okay. So there very well could be cold frontal passages, after a while we're talking about late December, early January. So you are going to get some cold fronts that come through here across the eastern U.S. But the air just doesn't look very cold behind the cold fronts at this point in time. You might drop off maybe 5 to 10 degrees after cold frontal passages, but in general it's going to be fairly mild. Now, La Nina still there. Strongly zonal west to east Pacific jet stream definitely going to be playing into this. A strong, more symmetrical or circular shaped stratospheric polar vortex and neutral teleconnections. Those are all going to result in a milder period for the eastern U.S. as we head into early January. There's no sugarcoating it. There really isn't. Now, with the milder temps, especially in the eastern U.S., I've seen this all the time. Where I'm at, where you get milder temperatures, usually in the wintertime you're going to get increasing clouds and you're usually going to get some sort of rain. Very rarely do you get, like in the spring, late spring, or in the summer, you can go the entire day where it's dry and it's just, the sun's out. That doesn't happen so much in the winter season in the eastern U.S. If you get milder temps, there's always a potential for multiple rounds of showers associated with passing storm systems. I actually see that happening between now and the first week of January. There's going to be multiple shots of rain across the eastern U.S. Due to the milder air in place. It just kind of coincides with each other, milder air and moisture in the winter season. One other thing I didn't mention is, there's always a potential as very cold Arctic air masses gradually transition, the air mass modification takes place. You can get, once you get light southerly winds, sometimes you can get some pretty thick fog in place overnight. You got very long nights. And you are talking about the winter season, so the temperatures or radiational cooling conditions are usually more ideal in the winter season. And so as you get some of those light southerly winds initially to set in over a very cold ground, that can lead to some sort of thick fog in the morning hours. So that's something to watch coming up here, specifically across the coastal areas of the mid-Atlantic. And then finally, my last slide tonight, there are signs of a return to colder temperatures across the eastern U.S. by middle January. I'm skeptical right now. I'm very skeptical right now. It looks more like a progressive pattern. I'll get to that in here in a moment. But in general, there's signs of a return to colder temps across the eastern U.S., more winter-like at least, by middle January due to a positive PNA pattern. That would be where you get the higher upper-level heights across the western U.S. And then we could be looking at the potential weakening or elongation of that stratospheric polar vortex. Now, will there be a bigger disruption to the stratospheric polar vortex? We don't know that yet. Nobody knows that yet. You can show me models all day long about what is projected to happen, but will it exactly happen the way you're projecting it? That's the question here. I was reading somebody's comments today about how it's very difficult, the models, to latch on to changes to the stratospheric temperature profile, for example, the warming situation I talked about, more than 10 days out. So, it's always good to remain optimistic and show really cool graphics of potential weakening polar vortex, but, it's all skeptical in my mind until we get closer and we continue to see those trends of showing that weakening of the vortex. So it's just something to keep an eye on. Now, recent ensemble model runs today, on the 27th of December, I've been looking at this. they're indicating more of a progressive west to east upper air pattern. So that means generally what we're looking at, lack of strong high latitude blocking, lack of strong upper level ridges in the high latitudes on the Pacific and the Atlantic side. Just don't see it. So then you get more of a zonal west to east jet stream when you have a lack of blocking, high latitude blocking, upper level ridges. And that leads to the movement of troughs rather quickly, the troughs of ridges from west to east across the U.S. And lack of blocking also, you get no longer duration mild or cold temperature periods. Things kind of move from west to east rather quickly. If we see a stratospheric warming event leading to a significant weakening of the polar vortex, where we see decreasing zonal winds and reversal of the wind direction in the stratosphere, and a turn to a colder MJO phase, potentially towards phase 8, then we do have the potential to see a much colder period in late January across the eastern U.S. If there's one thing I learned most about over the years with the atmosphere, is it's about timing and location. And, if those two things come together, then you could really see a wintry period. But again, those things have to come together and work together, like both the timing and the location of features. Now, there's many hypotheticals at this point in time. In other words, there is a lot of uncertainty in either direction, whether we're talking about warmer or colder periods as we head into January, beyond that 5th of January, beyond the first week of January, I'm talking. As we get to mid and late January, there's just a lot of hypotheticals right now and uncertainty. The pattern of colder late month periods, I will say, has been rather interesting to this point. Since late October, we have seen, let's go back to late October and I'll talk about it here briefly. So late October, the eastern U.S. saw an unusually cold air mass with a deep trough. So we had colder than normal temperatures coming in late October. Then almost the same identical patterns showed up about 30 days later in late November, to where we had another period of extremely colder than normal temperatures in the eastern U.S. in late November. Then we had this one now around the Christmas holiday, a very, very cold, anomalously cold Christmas for many in the eastern U.S., all the way down to Florida. And so now, are we due for another anomalously colder than normal period in late January? It just seems like the atmosphere is working in a repetitive cycle here. There's no guarantees the atmosphere is going to perform the same in the future, but I think it's just an interesting point. If you're a good observer of what's happening with the weather, sometimes you can kind of connect those dots. The atmosphere kind of gets stuck. It's kind of like, where, let's say you're watching a movie and like something gets stuck and it keeps replaying the same section of the movie, right? So it's possible it could happen. We had a milder early November period, we had a milder early December period, and now we're projected to have a milder than normal early January period. So if things are working in 30-day cycles, this would then line up another colder than normal period in late January. Now, why is that important? You want to bring in colder than normal temperatures, deep troughing in late January now. Now we are in the climatological peak, or the climatological norm for wintry precipitation for many locations to the mid-Atlantic North in late January. So, just here in southeastern Virginia, our sweet spot as far as dates go for any wintry precip, including snow, is generally from mid-January to mid-February. That's where I look at my max window of opportunity here. But of course, further north into New England, that period lasts longer than just mid-February. But it's going to be interesting to watch if the cycle continues to where we get colder than normal temperatures in late January. The La Niñas continue to forecast a weaken as we progress through January and February. It'll be interesting to see if we get any high latitude blocking, some strong high latitude blocking to redevelop, to kind of disrupt that Pacific jet stream. Well, it's going to be interesting to watch, but that's all I've got for now, everybody. I hope you enjoyed tonight's video. It's been a little bit for me, but just like you, I've been, just really enjoying the holiday season, and I really, again, hope that everybody's having a great holiday season at this point. If you live in the eastern U.S., enjoy the mild New Year's Eve, and when you get out there, and I'll keep watching the trends of the models. But right now, things are looking pretty mild and uneventful. We will see some periods of rain. with cold frontal systems moving in, as well as some storm systems moving in, and the air's just going to be completely too mild for wintry precipitation the way it looks right now, at least through the 5th of January. But that could change, and the upper air pattern can change, and that's what makes weather so exciting. It changes from day to day, and you might be mad at one set of models, one model run, and 6 hours later that will completely turn around and drive you completely insane, and you'll be completely happy, and you'll be like, oh wow, look at this, it looks colder and we could have a nice winter storm. 6 hours later it switches back to warm and you're disappointed again. So that's what it's like to be a fan of winter weather. So that's all I've got for now, everybody. Until next time, take care, God bless. I want to wish each and every one of you a very happy new year, a blessed new year as we make that transition to 2023. All right, everybody, take care. Until next time, God bless everyone.